As you can see in the next graph, shipments of photovoltaics, solar cells, for example, have increased over the years as well as declined in price. Wind power has also increased its share of generating capacity to close to 3,000 megawatts, shown in the next chart. Besides utilizing renewable sources of energy wherever possible, one can reduce the need for fossil fuels by reducing energy demand. In the electric sector, this usually takes the form of demand-side management, or DSM. Mr. Sandoval will discuss in detail DSM programs later in this program. For now, I just wanted to show you that this is big business in the United States. The next graph shows how much money is spent by United States utilities on DSM. This amounted to close to $3,000 million in 1993. Demand-side management programs have not only reduced the need for additional generating capacity, but also has created new markets and industries for energy-efficient technologies, such as compact fluorescent lights and highly efficient motors. The impact of effective DSM programs can be seen in the next graph, which shows how California, which has led the way in DSM in the United States, has reduced its per capita electric use significantly compared to the rest of the country. I will conclude by saying that energy use affects every person and organization on Earth. We live in a global system which is growing more and more independent. Energy is a critical component of that system. For most countries, it is a strategic resource and figures strongly in a nation's global competitiveness. We owe it to ourselves and to future generations to use our energy resources wisely and in the most efficient way that we know how. Thank you.
Let's begin the first question and answer session. We will try to answer as many questions as possible. Therefore, we ask that only one question be asked per phone call and that these questions be as brief as possible. You may call the studio directly at the phone or fax numbers which now appear on your screen. And please remember to stand away from the monitors so that we don't get electronic feedback. Thank you very much. We have as our first question a fax from Fenalco, Antioquia, Colombia. And it is, what is the most appropriate way to generate a culture that supports the conservation of natural resources? And Dr. Sweedler, I might ask you to respond to that if you would.
Thank you, Frank. Well, that's a very deep and important question because I think that goes to the heart of the issue of conservation and energy efficiency and using resources effectively. I think it should start very early in age, possibly even in the family, where young children are shown by example that using water, electricity in the home carefully, turning lights out, not leaving televisions on, things of that nature, inculcates in them the respect for energy and resources. Some other possibilities might include actual incentives during the, as children grow up. These can be giving little awards, things of that, science fairs where energy conservation is a theme. And one area I think that could be helpful too is that most people never know how much energy they're using. They just turn a light on or turn a radio on. It might be helpful to have some sort of continuous metering where people actually see what they use. So this is a very critical issue, and I believe it starts very early, and there needs to be some public values attached to using energy and resources effectively.
Thank you, Dr. Sweedler. We now have a live question coming from Universidad Iberoamericana in Torreón. Go ahead, please.
Good afternoon. The question is, what possibilities are there to make the energies, to adapt them to the use, for instance, solar energy and, let's say, in the other geothermal energy to industrial uses? How can we adapt that?
I could try that. Solar energy is usually in two forms, either for electricity, solar cells, or thermal. And geothermal energy, of course, is the production of heat. Many industries all over the world use particularly the thermal aspects of solar energy for process heat. Using parabolic collectors, it's possible to generate very high temperatures, which can then be used in any sort of industrial processes where high temperatures are required. This is generally quite cost-effective. Geothermal energy, of course, is used mostly for the production of electricity, but in some countries, Iceland, for example, it's also used for the production of heat and the use of heat. And so if the resource is available, it makes sense to use both the heat from the geothermal resource as well as the electricity that can be produced from that heat.
If I might offer a supplement to that, in terms of whether electricity from those resources can meet the rapidly increasing needs of an emerging economy, I have some reservations for two reasons. The first is principally economics. New fossil-fueled, natural gas-fueled power plant using a combined cycle technology can be built at about 3.5 cents per kilowatt, produce power at about 3.5 cents per kilowatt hour, or installed cost maybe $700, $800 per kilowatt. Energy from solar sources and from geothermal is likely to be more costly. And secondly, there really are not a lot of places in the world from which you can derive geothermal energy. So I suspect that the likelihood is that most of the new generation needs will be met largely through fossil-fueled power plants.
Thank you. I expect we'll be coming back to some of those issues. The next call is another live call from Unión Industrial Paraguaya in Asunción. Go ahead, please. Are you there?
Buenas tardes.
Buenas
Good
tardes.
afternoon.
Estamos aquí en la Unión
We are here.
Paraguaya con una concurrencia
We have a very distinguished audience here, many people of various executives of the energy sector. The question comes to you from the electric enterprise. What are the levels of losses that the Mexican enterprises have, both Mexican and Costa Rican, when it comes to generation, transmission, and distribution of energy? And what are the levels of loss in those countries?
Which of you gentlemen are there?
Well, I'm not a specialist in detail on the Mexican electric sector, but I do know, I have heard various figures presented for transmission losses that can be as high as 10% or more. And I understand they are working very diligently to reduce those losses. The electric sector itself, of course, as you know, only produces about 1/3 of output energy for every 2/3 input if the technology is a thermal process. That just follows from the laws of thermodynamics. There's not much you could do about that. But you can, in very efficient plants, generate up to 40% of the input energy can be converted to electricity. My understanding is, at the moment, in Mexico, that number is somewhat below that.
Thank you, Dr. Sweedler. Next, we have a call from Universidad Tecnológica de Panamá. Go ahead, please. Go ahead, please.
What will be the cost of producing energy, electric energy with fossil fuels, and what will be the impact in the economic development in the developing countries? Thank you.
The cost in American for a new combined cycle power plant runs about between 3 and 4 cents per kilowatt hour. In terms of the cost of the capital per kilowatt, in the neighborhood of $700 to $800 per kilowatt. So if you're constructing, say, a 200 to 250 megawatt power plant, you can expect that that's going to be in the neighborhood of $150 to $200 million capital to construct it, and typically that would be financed on the basis of maybe 70-75% debt, 25 to 30% equity. And I think that probably those new generation will largely be fossil fueled, as I mentioned earlier, ideally natural gas using the combined cycle technology, and most of the new generation that's being built internationally and indeed in the United States is that technology at that cost.
Very well. We now have another call from Instituto Tecnológico de Tlalnepantla. Go ahead, please.
Estado de México. About saving energy, what are the trends or alternatives of energy resources in order to reduce costs and pollution?
Would you like to try that?
Sure, I can. I can describe or briefly summarize some of the types of technologies that are available to industrial and commercial and actually residential energy users to improve their energy efficiency. These kinds of technologies typically will help a plant to lower their energy cost and boost their modernization efforts, as well as improve their industrial processes. There are a lot of lighting technologies commercially available. There are energy efficient motors and motor technologies everywhere from variable speed drives on variable process flows to energy efficient belts, gears, motors. There are a whole array of technologies in the refrigeration and air conditioning technology group, as well as in compressed air. And as I mentioned, these technologies are currently available on the market. And they offer the opportunity of greatly enhancing the industrial competitiveness of businesses that adopt these technologies.
Thank you very much. Let's go now to another question by telephone from the Comisión Federal de Electricidad, LAPEM, Irapuato, Guanajuato. Please tell us your question.
Thank you very much. I would like to know what the role is for the real price policy or the marginal cost in order to reduce the index, the rate of energy intensity in development.
The real versus the marginal costs of energy development.
Okay. The trend in the United States is to move more towards marginal cost regulation of energy prices, because that sends a truer economic signal to the user, who then can make choices based upon economic principles. The traditional method of regulation in the United States has been on the basis of fully allocated embedded costs, which means you take all of the costs of providing a service, those are original costs, and spread those over the amount of kilowatt hours one expects to sell, and the result is a price per kilowatt hour. Being based upon embedded costs, that doesn't tell you anything at all about the actual incremental or marginal cost of generating the next increment of power to meet a particular need. So false economic signals were being sent, which occasionally resulted in power plants being built that weren't needed, or transmission lines not being built that were needed. or different technologies being used and should have been used. So the trend clearly is moving more towards marginal cost or pricing on the basis of the incremental cost of energy.
Very well. Let's move along now with another phone call from Instituto Tecnológico de Tepic in Nayarit.
Gracias. Del Instituto Tecnológico de Tepic.
The question is, given the influence and the importance of the ways of generating and the habits of consumption and the ecological habits in the world, do we have on a worldwide level some kind of organization or organizations that are promoting and giving incentives to improve the generation habits and ways of consumption of all the countries in the world, and how do they do this?
Perhaps Dr. Sweedler, you could respond.
I'm not aware of a global agency that has particularly that responsibility. Okay. Yeah, there isn't. Okay. There are agencies that monitor these things. I mentioned one in my comments, the International Energy Agency. But there are indirect methods that are used. The agreements on global climate change, of which some countries have agreed to participate, others have not, indirectly encourage or the use of less fossil fuels, at least, to keep carbon dioxide levels at levels predetermined. So that encourages conservation. I think, though, the most useful and likely to give results approach is the market approach and sending the right price signals, that when energy is subsidized and it costs less than the replacement energy, the marginal energy, people will inevitably use it as if it's because they think it's cheaper than in fact it actually is. And we have lots and lots of experience that shows when the cost of energy is priced at its true value, efficiency goes up and better use is made of resources.
Thank you. We have a call from Comisión Federal de Electricidad, Museo Tecnológico. Go ahead, please.
Good morning. I don't know if you could maybe elaborate a little more or refine this a little bit more about the Mexican situation from 1973 to 1994, I think, because during that time we have had new industries and we have had new big industries, plants like the cement industry, and so we don't think that the energy has diminished, but we have more industries now that have a lot more, that consume a lot more energy, so we have an increase in the energy use.
And clearly that's for Dr. Sweedler.
I think what you're referring to is some of the comments during the module. You are correct in that as a country grows, of course, and its industrial capacity base increases, it develops industries which use more energy. But the experience in the OECD countries, Western Europe, North America, and Japan, has been that the amount of energy that's used is not correlated to the amount of economic growth. You can have high economic growth but lower energy use. And the way you do that is by using energy efficiently. It's not the quantity of energy that's used, it's how efficiently the energy is used. So in the cement industry, of which Mexico is a major participant, what one wants to do is produce a certain number of tons of cement, but each year use less energy to do that. This has been accomplished in the aluminum industry, it's been accomplished in the copper industry, and in certain countries also in the cement industry. And I think that's the goal to attempt to achieve.
Thank you. Our next call is from Instituto Tecnológico de Apatzingán. Go ahead, please.
Tecnológico Superior de Apatzingán. Buenos días.
Good morning. Our question is, what would be the kind of source of electric energy generation that would guarantee a real ecologic conservation, preservation?
That's a very tough question because I think that inherently associated with the generation of electricity is some adverse environmental effects. It can't be avoided. If you're going to burn or have a thermal process, there's likely to be some air emissions. There will be some adverse effect on the natural environment in some way. There are differing views on the kinds of processes that will be least environmental damaging. New combined cycle technology using natural gas emits far less than 10% of the oxides of nitrogen emitted by power plants that were constructed perhaps only 20, 25 years ago and now are being required to be retrofitted with very, very expensive pollution control devices. Certainly the use of renewable resources would be environmentally advantageous. Wind, solar, responsible development of hydroelectricity, which often has not been done in the United States, for example.
Thank you very much.
DSM, it's probably the foremost way.
It's a large topic. We next have a phone call from Cimentos Pasco in Tabasco, Mexico. Go ahead, please.
How does the United States achieve reduction of energy, as we have said, vis-a-vis Mexico? So versus Mexico, what is the advantage that the United States has? How have they been able to do this?
Well, I can give it there's a spectrum of programs that are used in the United States, and more specifically in California. Some are government regulations, which is becoming less important, I think, as time goes on. There are initially there were certain tax incentives through the tax code for investing in certain types of energy technologies. There are demand-side management techniques that Mr. Sandoval will discuss shortly. And there is mostly, the most important thing, I think, is that the economic system, and particularly the tax system, is structured in a way that sends the proper signals to those companies that use energy efficiently. In other words, it doesn't reward a company, for example, by using the amount of fuel as a business expense. So the more fuel the company uses, the more tax deductions they get. That's sending the wrong signal. The proper signal should be the most efficient use of the fuel that they use results in the greatest profit for them, which is ultimately what they're interested in. So I think in the United States, restructuring of the tax system has been very important. And also the recognition that from the consumption side, the more energy you buy, the cheaper it shouldn't be. It used to be a time that the more you use, the less it costs. It works well if you're selling products of some cars or something, but if you're buying energy, we now have a system which is more rational, that the more you use, the more you pay per unit, and that sends the proper signal.
Thank you very much. We now have a call from Universidad Estatal a Distancia in San Jose, Costa Rica. Go ahead, please.
Good morning. We would like to congratulate Dr. Cardenas for this wonderful, or the experts for these wonderful presentations. We would like you to give us your opinion on the future in hydrogen technology in the future, and we would like to know how, what the price of the electric bill has, what role it has played in the United States conservation of energy.
Hydro technology.
Hydro, not
yes.
hydrogen.
Mm-hmm. Mr. Oglesby, would you like to respond?
Hydroelectricity has played a major role in the United States. For example, In the Western Systems Coordinating Council, which is the reliability council encompassing virtually all of the western United States portion of Mexico in 2 Canadian provinces, the single greatest source of generation is in fact hydro. About 50% of the generation in the WSCC is hydro, and a little bit less than 50%, but very close is the other, all other. In the United States, it is generally felt that most of the good hydro development has already taken place. There are those who would argue that I should not have used the word good, but nonetheless, it is not expected that there will be significant hydro development in the United States. Hydro is looked to in a number of other countries. Of course, many people are familiar with the Three Gorges project on the Yangtze River, in encountering a good deal of controversy. There has been controversy relating to some of the massive hydro projects in Canada. Hydro-Quebec has declined to build. It's only a personal view, but my personal view is that the future of meeting electrical demand is not found in hydro.
Okay, let's leave it at that. Perhaps we'll come back to it. Our next call is from Unión Industrial Paraguaya in Asunción. Go ahead, please.
Good afternoon. I can't hear. The question is, por favor, aléjese del monitor. What perspectives do you have in the near future of the practical application of nuclear and superconductors energy in the electrical sector? Se ruega a las personas.
The matter of nuclear.
All right. I think there's unlikely to be much of a future for nuclear, given the present state of the technology. Perhaps with some future generations there may be, but in addition to the controversies associated with the safety of nuclear power plants, there is the issue of the extraordinarily high capital cost associated with their construction, and most investors are disinclined to trust huge amounts of capital to nuclear facilities, with the likelihood that the cost will not be economic. You can build a much cheaper, more power plant using more conventional technologies. As to superconductivity, I really can't speak to that. I don't have the knowledge.
Very well.
I don't think there'll be a major impact in power transmission for superconductors for quite some time. Superconductors are making some inroads in other types of applications, sensor technology, but not in the power industry, in my view.
Thank you very much, gentlemen. And now I would like to ask our invited panelist, Mr. Douglas Oglesby, to share with us his insight on some key issues of our video conference topic. Mr. Oglesby, what can you tell us about the regulatory aspects of electrical power companies or utilities in California and in the United States in general?
The traditional way that utilities are regulated in California, and it's the same nationally, is based on the economic principle that electric utilities and the provision of electrical services is a natural monopoly. And also recalling that the great majority of electric utilities in the United States are privately owned, this has created the need for economic regulation, which is typically provided at the state level by public utilities commissions, or in some states they're called public service commissions. And these commissions regulate on a principle that's come to be known as the regulatory compact. Under the regulatory compact, the utility incurs an obligation to serve all who desire service, and unlike any other privately owned business, you can't decline to serve and walk away. The rates with which the utility charges its customers are regulated. The amount of money that the investors are allowed to earn on their investment is also regulated. then the utility incurs an obligation to construct. It has to build new utility plant to meet the needs. In exchange for this, the utility gets an exclusive right to serve in a geographic area called the franchise area. So the balance is utility is protected from competition on the one hand, but has its rates, charges, and the ability to earn on the other. Now that is breaking down. That is breaking down in many states, and it is breaking down, as I mentioned,